Hello everyone, welcome back to our YouTube channel. This is Clarice Lim. Today I'm going to show you P3 Science magnets. Okay, so the purpose of this videos is really to do a quick revision review on the key concepts on how to answer section B open-ended questions and how do you fill in the blanks using the correct answer, because a lot of times the students don't know how to answer those kind of questions and they end up giving the obvious answers but not getting a single marks. Okay, so this is very concise science topic introduction for the kids to really understand how you should answer the questions in order to score points. Okay, so it is very concise, it is as straightforward as possible so that it gives you a very clear idea of how to answer the questions in your exams. All right, so magnets. A magnet attracts magnetic materials such as iron, nickel, cobalt, and steel. Students, you need to remember these four materials, magnetic materials, INC. So what is INC? INC is actually short form for corporations. Okay, so I remember it this way: INCS, magnetic materials. I for iron, N for nickel, C for cobalt, S for steel. Okay, why is S is a small s? Okay, because steel is actually an alloy from iron. Okay, alloy means it's a mixture of materials, right? Okay, so steel is an alloy of iron, that's why it's a small s. But remember, inks, magnetic material. Magnets have two poles, north and south. Okay, you already know that. A freely suspended bar magnet comes to rest pointing in a north-south direction. I'm not sure if you've done experiment in school before, but if you have not, here is a video to show you. Okay, so what's happening in this video is that if you place the magnet, you see that this is a north, this is the south. So the magnet will turn one round and make sure it points, the north side points to the north of Earth. Okay, that's what happens. A magnet will always point towards the north. The north side of the magnet will point to the north side of Earth. So this compass tells you that this is north. Correct? So all magnets have north-seeking and south-seeking poles. So the other side will be the south. Right? Okay, now let's come back to our worksheet over here. So the pull of a magnet is called magnetic force. So what is the meaning of magnetic force? So you will see that, okay, so the north and the south, so these are literally the lines around the magnet. How do I know? Okay, let me show you another video over here. So this is how the magnet looks like. In this video, they actually put a magnet under the paper. So after they put the magnet under the paper, what they did was they pour iron fillings. Remember, iron is a magnetic material. So the iron fillings will be attracted to the magnet under the paper. Okay, so as they pour, you will see that the pattern beautifully comes out. And it is circular in shape. So you see, because the magnet is so strong, the iron filling actually spikes upwards. And then it will curl around the magnet. So they will show you a close-up over here. And there's both ends to the magnets, right? So this is actually how the curls look like. This shows you the force around the magnet, okay? So how does the force around the magnet looks like? If you want to, I can also show you another picture over here. So this is how the force of the magnet looks like, okay, in lines like that. So usually in test papers or in visual graphic, they will show it to you like this in lines. So you'll be thinking, why is the magnetic force in lines? But they are in lines, right? Okay, so when you point the north to the south together, what happens is they attract each other, like pulling, like shaking hands. It's like, oh, you're friends with me. Okay, let's shake hands, let's bond together closely. So that's when the north and the south attracts each other and they closely bond each other. So it's difficult to pull them apart. But if both is north, okay, so what happens is they will push each other. It's like, I don't want to be friends with you, I don't want to shake hands with you, we are different, or we are the same, sorry, we are the same, I don't want to be with you. Okay, so what happens is the force will be repelling each other, they will not come together at all, right? So this is what is shown over here. So the forces are basically just pushing against each other, they will not come together, they will not shake hands, right? So in summary, what happens is north and more north, they repel. The word is called repel. You cannot say push, okay? In the correct word to use in the exam is repel. And north and south, they will attract. So use the correct scientific word. So this is attract, north and south, they attract each other. North and north, they will repel. South and south also repel. So what happens is, Magnetic force is able to pass through non-magnetic materials. So what happens if this is a magnetic material, north and south, they will just pass through, and then they will attract. They will like, oh, okay, you're a friend, I will hold on to you, and then they will be able to attach to each other firmly. But what happens in a non-magnetic material? Let's say this block is non-magnetic material, nothing happens. It's just nothing happens. It will just go on. The magnet will be just closed up by itself. The magnetic force just goes around the whole material as if nothing exists. Okay, so magnetic force is not affected by non-magnetic material. Okay, it will only bond, the magnetic force will only bond with another magnetic material and holds it tightly. Okay, so remember that non-magnetic materials include, there's many actually, some of the examples are glass, wood and paper. No effect on magnetism. Magnetic force is also called magnetism. Okay, so iron and steel can be made into a magnet by, number one, stroking. Okay, as you stroke, the place where you land over here, if you are using this as a north and you land it over here at the head of the nail, the north side landing on the north part, landing on the nail at the head part, the head will therefore be north, the lifting part will be the south. That's how you determine the polarity when you do a stroking method to make the magnetic material magnetized. Okay, so in order to magnetize the magnet, you stroke it as many times as possible. The more times you stroke, the more magnetized it becomes. But it's only a temporary magnet, meaning the magnetism will lose its effect eventually. Okay, so it is not a permanent magnet. If you want it to be a stronger temporary magnet, what you can do is use a stronger magnet or stroke more times, like I said just now, right? So if you stroke even more times, there will be even more paper clips that can hang from this temporary magnet. Another way to create temporary magnets will be through electromagnets, which means to coil wires around this iron nail, and you can temporarily make this iron nail into a magnet. So this paper clip is to show you that it is actually attracting a magnetic material, which is paper clip. Okay, in order to increase the strength of the electromagnet, remember this, increase the number of coils. The more rounds of coils you put around the iron nail, the stronger the electromagnet becomes. Okay, very common question in exam. They will always ask you, how do I make the electromagnet stronger? By coiling a lot more times. That's the answer. Okay. Some uses of magnets in our everyday life, for example, in refrigerator doors. How does refrigerator door use a magnet? Let me show you another video over here. So this is the refrigerator doors magnet. Okay, you might not notice. Maybe you can go and open your refrigerator. It might be hidden. Okay, in this case, this is actually shown. It's quite simple to see. It's easy to see. So you can actually remove it. This video actually shows you how to remove the magnet, and it shows you exactly how the magnet looks like inside the refrigerator door. So what is the magnet used for in a refrigerator door? To make sure it closes shut. Right? You don't want the refrigerator to have cold air coming out, otherwise your ice cream and your eyes will all melt. So you see, if you take out that plastic holder, you will see the magnet inside. And this magnet is squarish in shape. Now, this is the new magnet. So they will install the magnet because magnet can actually lose its strength over years. So if you replace it with a stronger one, the door will work the same again. Okay, so this is the magnet used in doors of refrigerator. In a compass, just now already see a compass, right? The compass will always have a magnet inside because magnets, when freely suspended, it points to the north of Earth, right? So you can use a compass to find the direction of where you want to go because it will always point at Earth. If you're heading south, you will always, if it points at north, you know the other side is south. Okay, so you can actually turn the magnet around and then you see how you can maneuver yourself and walk towards east or walk towards west. Okay, you get what I mean. Separate magnetic and non-magnetic materials will be at car scrapyards. Okay, what does that mean? So this kind of big, huge electromagnets are very common at car scrapyards, at incinerators, because they will use these magnets to attract all the magnetic materials which can be used to recycle. Right, so once it's attracted, they will switch off. They will turn this magnet to another place where they collect all the metal scraps, and then they will switch off the electromagnet, which will then release whatever is attracted to the electromagnet, it releases into a huge collection point, and then they will use all the magnets that is collected to recycle. All the rest burn, okay, because they are not useful anymore, burn into ashes and bury, right? That is how we treat trash, okay? So what else can you use magnets for? You can also use it in electrical appliances. A lot of electrical appliances have it, example refrigerator, and also your computer. Okay, so it is used in a computer, laptops, to generate electric current. Okay, we shall not go into the details, but one example I can show you here is, why do you think the paperclip is standing at the end of the laptop here? Because the magnet is actually found inside here. It might not be the same point for every single laptop, okay? But over here, you can actually use a paperclip to find where the magnet is on your laptop. This is not magic. It's just magnet holding the paperclip standing, right? Let's try some questions. For magnets, Jingming conducted an experiment as shown below using 3 different magnets. So he keeps changing this magnet over here. He uses magnet A, uses magnet B, uses magnet C. So he measures how far apart the distance is over here in order for the paperclip to move towards the magnet. Okay, so he moved magnets slowly towards the metal clip and recorded the distance that it takes for the metal paperclip to go towards the magnet. He repeated the experiment with magnets A, B, and C, and then he recorded the results over here. So the distance needed to attract the metal clip, for A, you need to go as close as 7 cm. For the metal clip to zoop, go to the magnet. Magnet B, you can take 11 cm. That means it's even longer, isn't it? Remember the lines that we've seen for the magnetic force around the magnet, which means the force around that magnet B is actually much bigger. It can cover a longer distance before the paperclip gets attracted. But for C, it's very short. The magnetic force of C is so short that you need to go very, very close in order for the metal paperclip to go towards the magnet. Okay, which means which magnet is the strongest in this case? Very obvious, B is the strongest because the magnetic field is bigger. It can attract the metal paperclip at a further distance. Okay, so B is the strongest. So how do you explain that? So of course you need to write magnet B first. It can attract the metal clip at a further distance. That will be the key word, the further distance. It will attract. Okay, so the attract is the keyword as well. Of course, this one will fetch you 1 mark. So attract at a further distance. That will be the key words you need to use in order to explain this question. Right? If not, you can also use the keyword magnetic force. Okay, the magnetic force of B is stronger, therefore it can attract the paperclip at a further distance. Again, the further distance must be written inside in order for you to score that full marks. When Jingming used the paperclip, made of another material, okay, the clip was not attracted to the magnet. What is the reason? Very simple. That material is not magnetic. It's not a magnetic material. Okay, so you can also say it is a non-magnetic material. Okay, so this will be the keyword, non-magnetic material. The only reason why magnets doesn't work on any kind of material is because that material is non-magnetic. Okay, Lydia set up an experiment as shown below. South and south is pointing towards each other. Remember just now I told you, if it's the same pole, they will not shake hands. They will want to repel each other away. So what happens is, if you continue to push magnet A towards B, B will say, don't come near me, don't come near me, don't come near me. They will go further and further away. So what happens to the toy car behind magnet B if you keep pushing A this way? The toy car will fall off the table, isn't it? So the question is, what will happen to the toy car when magnet A is brought closer to B? Explain your answer. And the answer is because south and south are like poles. Keyword, they're like poles, and therefore they will repel each other. Okay, so that is the answer that we will use for this question. So the toy car will fall off the table. That is 1 mark over here. Okay, so the like poles, again, you see the keyword over here, the like poles of magnets A and B are facing each other. Therefore, when magnet A comes closer, you really need to explain yourself. Otherwise, the teacher will minus marks for unclear explanation. But the keywords is there. It will make you very, very safe. Okay, so they will repel, another keyword over here. Light poles repel, thus pushing magnet B backwards, which pushes the toy car off the table. Okay, so that's how you answer the entire question and get your 2 marks using these keywords. Light poles repel, toy car fall off. All right. So what should leader do to magnet B if she wants it to move towards magnet A? So very simple, just turn the magnet around. So that's how you answer it. Turn magnet B such that the north pole is facing the south pole, and so they will attract each other. So these are the keywords, right? Turn the magnets around. Like poles, okay, unlike poles will attract. So if you don't want to write the north pole is facing the south pole, you can also say unlike poles, so that you turn the magnet so that unlike poles will attract each other. You can also get that. Okay, so the keywords is very, very important. Let's look at the next question. Linear centered experiment has shown the moment you see battery, iron rod, curling of wires around it, you know this is a electromagnet. Correct. So she has 3 setups, A, B, and C. Each setup consists of a similar iron rod, the same thing, and the same number of coils. The only thing that she changed is the number of batteries. Okay, so setup A has got 1 battery, setup B 2 batteries, setup C 3 batteries, and the number of thumbtacks it attracts by the iron rod, which is a temporary magnet, grows in numbers as the more batteries you use. Okay, so 1 battery only 3 thumbtacks is attracted, 2 batteries 6 thumbtacks attracted, 3 batteries 8 thumbtacks attracted. So what does that tell you? What is the relationship? The more batteries there are, the stronger the magnet, therefore the more thumbtacks attracted. All right, that's the relationship you observe. So let's answer it one by one. What is the aim of Lina's experiment? So what did she want to do? She wants to find out the strength of the electromagnet. Okay, so you can also say to find out if the number of batteries affects the magnetic strength of the electromagnet. So the number of batteries over here is your keyword, right? And you have to talk about the magnetic strength of the electromagnet. So the number of batteries, whether it affects the magnetic strength. This is the 2 keywords for you to get the answer correct, for you to get the points, okay, offered for this question. Give an example of a material that the thumbtack is most likely made of. Okay, remember inks, iron, nickel, cobalt, steel. Any of them will be a correct answer. Okay, so in this case, you can either write iron or anything. Okay, write iron then. So by replacing the iron rod with an aluminium rod, will the experiment still work? Remember, magnetic material, iron, nickel, cobalt, steel. Aluminium, no, not inside. Aluminium is therefore a non-magnetic material. So if you replace it with a non-magnetic material, will it be magnetized still? Of course not. Only magnetic material will be magnetized, right? So aluminium is not non-magnetic material, so therefore that's what you have to say. This is the keyword, non-magnetic material. It cannot be magnetized. That's the keywords for this question. Based on the table, what is the relationship between the number of batteries used and the number of thumbtacks attracted? So whenever you see the word relationship, you will know that they are asking you for the more the something, the less the something, or the less the something, the more the something. That's the relationship they are asking you to have. So how would you answer that? You will say, as the number of batteries increase, the number of thumbtacks attracted also increase. That's your answer. Okay, so you must have 2 increases. One of them is the battery, the other one is the thumbtack, and you get your full marks. Okay, let's look at another question. So Ben wanted to make 2 temporary magnets. Remember, temporary magnets, you can either stroke or use electromagnetism. He used a strong magnet to magnetize objects X and Y. Okay, so the X and the Y are both magnetic materials, or are they? What is the question asking for? Let's take a look. So as he strokes and strokes and strokes and strokes, Ben then brought the temporary magnets near some steel paperclip. Steel is a magnetic material. Remember, INCS. He recorded the results in the table below. So X did not attract anything. What does that tell you? X is not a magnetic material. That's why it cannot become an electromagnet. It doesn't attract anything, isn't it? Right? So this is the thing that you learned in magnets in this chapter. Non-magnetic material can't attract anything, can't be magnetized. Magnetic material can become a temporary magnet. That's the concept you have learned, and that's what the question is testing you for. So which object is not made of a magnetic material? Obviously, answer X, right? So using information from the table, explain your answer in A. How do I know it's X? Because it did not attract any magnet, right? So it may sound obvious. It's like, why is it so simple? It's okay, don't worry. They are testing you on a concept of whether you understand only magnetic materials can be magnetized. So if they ask you the other way around, it sounds obvious. That's the answer. It's okay, no problem. It did not attract any paper clips even on the third try. So suggest two ways in which object Y can be made into a temporary magnet, a stronger temporary magnet. As mentioned just now, you can stroke it more times, okay? If not, what else can you do? You can also use a more powerful magnet, okay? So if they use a more powerful magnet, it will induce more magnetic field, more magnetic force onto the material that you're stroking, okay? So remember this too. How do you increase the strength of a temporary magnet? By stroking it even more, okay? Or use a more powerful magnet. If it's electromagnet, coil it even more, or use a stronger battery, also can, right? Okay, last question. Yiting was told that the magnetism can pass through non-magnetic materials. She set up the experiment below. She placed the magnet in a glass box, okay? So this is a glass box. The magnet is inside. And then she placed iron nails inside the paper cup here. What will happen to the iron nails? Remember, non-magnetic material does no effect to the magnet, right? So what is going to happen? Nothing is going to happen. The magnet will be able to attract the iron nail. So the magnetic force will pass through the glass and the iron nail will get attracted to the magnet. That's all. So nothing will happen. So the glass will not block the magnetism. Therefore, you will say it will pass through the glass and the iron nail will get attracted. Okay, so this is what you need to write. The magnetic force will pass through and the iron nail will be attracted. So these are the keywords you need to write for this answer. Now, Yiting's mother, okay, uses this innovative thing to clean both sides of the window at the same time. So how does it do that? She controls one side, okay, and the other side is actually magnet, or rather it could be a magnetic material or it could be another magnet. But over here, the question is asking you, what are the poles? Okay, identify the poles of magnet Y over here at the other side where the mother is not holding. The mother is only holding this side. You see the handle here? The mother is only holding this side. But at the other side of the glass window, there is another magnet, another cleaning sponge. You see both sides, both of this dotted figure over here, rectangle over here, they are cleaning sponges. So what happens is the handle that the mother is holding is a magnet. At the other side of the glass, it is also magnet, and so they stick together. But how do you make sure they stick together? They must be unlike poles touching each other, isn't it? Unlike poles attract. Remember that? So what are the poles of magnet Y? Therefore, it is very obvious. How do I know? Because over here they say N. In order for the other side to be attracted, it has to be south, because unlike poles attract each other. Am I right? Okay, so what is the answer over here? It will be simply A is south over here, B is north. All right? So Yiting used the same cleaning device and set it up as shown below. Oh, she put both north. What's going to happen? She said Yiting's cleaning device did not work. So explain why Yiting's device did not work. Because like poles will repel, right? So Yiting had got north and north facing each other. Thus, the two magnets will repel and will not work. Okay, so the keywords will be like poles are facing each other. Okay, and they will repel. See, the keywords just keeps repeating and repeating. Unlike poles attract, like poles repel. These are the keywords you need to learn in this topic. So always remember, when you're answering science exam questions, always remember what are the keywords. Every single topic has a keyword. If you don't have a keyword in your answer will not get the full marks. Okay? So that's all for magnets today. Please click subscribe and get notified of our new videos. See you soon. Bye-bye.